Hey everyone, Nick Diobertis here teaching you financial modeling. And today I'm going to be talking about sensitivity analysis in Python. This is part of our lecture on exploring the parameter space. So we left off last time, we had gone through some additional Python basics that we were going to need to be able to carry out sensitivity analysis in Python. I was on list comprehensions, dictionaries, installing packages, and now we're going to go ahead and actually implement sensitivity analysis. So for sensitivity analysis in Python, we're looking at two main kinds of ways that we can visualize the output. So the new one, which is different from what we're able to do in Excel, is this hexbin plot that you see here. And this is analogous to the conditional formatting on a table in Excel, only in graphical form. So here, it makes regions of this two-dimensional area corresponding to the value of the outcome. So you have your two different inputs on the two different axes, and then your outcome is the color. And so here, high years to retirement is red, low years to retirement is green and getting darker green the more that it decreases. So we can see clearly from this graph that as savings rate increases and as the person gets promoted more often, then they're going to be able to retire sooner. The other main output that we have is exactly what we have in Excel, which is a table with conditional formatting applied to it. So this is showing the same information as the hexbin plot, only with each of the numbers in there as well. So it's mostly a personal preference with which one you want to go with, but these are the two main ways to look at the two inputs at once with sensitivity analysis and visualize that. Of course, with one way, then you can just plot that with a typical line plot. So the process to carry out sensitivity analysis in Python, if you don't want to use any packages, you just want to use pure Python, then it's basically you do a loop over each input that you want to examine. So you might say, I want to look at 30, 40, 50% savings rates. And so it'd be like for save rate in 30, 40, 50% in a list. And then you run the model with each of those inputs passed in, collect the results, keep them associated with which inputs are related to those outputs, and then put it all together to visualize. So then if you have more than one input, you just go ahead and do additional loops and nest those loops within each other. So for save rate and savings rates, for number of promotions in you know 2, 3, 4, 5, something like that, nested under each other, and then nested under all the loops is where you actually run your model with each of those inputs. Again, collect the outputs, associate them with the inputs, and then visualize it. Then you start to look at more than 2 or 3 inputs at once, and all of a sudden you're nested more and more in all these loops, and that can be pretty messy. So there is a way to resolve that. Python has a built-in package called itertools, tools for iteration, which goes a little bit beyond just what the base language does. And one of those basically allows you to do like a nested for loop, but with only a single line of code. So that's what this itertools product is. And so you can use that to then collapse however many loops you would have onto one line. But then it's a little more difficult to understand what's going on there. So I would, if you're sticking with this approach for sensitivity analysis, and we'll talk in a minute about a package we can use that makes all this much easier. But with the pure Python approach, I would say 2 or 3 inputs at once, just write out the individual loops. As you get more than that, then you should consider using itertools.product as a replacement for the nested loops. So here's an example of what that looks like, the code that can make sensitivity analysis happen with just base Python. So here we're saying that we have a function called model, and that's the function which runs our entire model. So it takes the inputs and then it spits out the result of running the model. So that can be, calculating the years to retirement from the savings rate, investment rate, etc., or any other model that you could possibly imagine. As long as you can always represent the model as a function, converting inputs to outputs. And so if you do that, then you can fit it into this structure just fine. So we have two different inputs we're trying to examine here, input 1, input 2. And for each of those, we have two different values of the inputs that we want to look at. So for input 1, we want to look at 1 and 2. Input 2, we want to look at 4 and 5. We set up a list to store all the results. And then here we have the nested loop. So we're going through each of these input lists, getting an input out of each one. And then within all the loops, calling the model with each of the inputs. Then we get the result from the model, and we associate the inputs with the output in the result here by creating a list of tuples where each tuple has everything grouped together. Then we create a data frame from that list of tuples, and we can see the results of the sensitivity analysis here in the data frame. Of course, this is not doing any visualization yet. That part is going to be added on after this. So this was kind of the process which is out there. This is what people are doing right now in general. And I thought that there should be a good package which makes this process easier, especially not only doing this, but then taking the result and visualizing it as well. But I really couldn't find any tool out there which was built for this purpose. I think a lot of that reason is because certainly a lot of financial institutions are already using Python and they're building models out in Python. But for the most part, these institutions are not going to be open sourcing their code. They're just going to be keeping it within the company as their own intellectual property. They want to have the rights to it and not anyone else. And so I think there have been a lot of these tools created, but they're just not out there for anyone to use. They're within these banks and financial institutions that keep a close guard on the tools that they've developed. So it really takes someone who both has the knowledge and is willing to be able to contribute to create an open source package without a lot of immediate benefit from it. So a professor teaching a financial modeling course is kind of the ideal person to do that. And unlike an Excel, you can write add-ons for Excel, but that's kind of heavyweight. And in general, people just use Excel as is. In Python, you have the base language, but then you have all these additional 250,000 packages, open source packages, which have been created to extend the functionality of Python. And it's really easy for anyone to create a package and contribute to the ecosystem, create a tool that solves a problem so that nobody else has to continue solving the same problem in their own work. So I went ahead and created the sensitivity package in Python, which simplifies this whole flow as well as the visualization of the results and makes this whole thing very easy. So I took the time to kind of solve this once in a general way, and now everyone in the world can benefit from my efforts. So that is really the big power of Python, that anyone in the world can contribute and it can make everyone else in the world more productive. So everyone's not reinventing the wheel all the time. So let's look at an example with the sensitivity package. So from sensitivity, we're going to import sensitivity analyzer. That's the main class which handles all this. And then you create a dictionary where the keys of the dictionaries are the names of your inputs, the arguments to the function, your model function, and the values are what each individual values of the inputs you want to look at. So 1 and 2 for input 1, 4 and 5 for input 2. Then you pass to sensitivity analyzer that dictionary of the inputs and your model function. And that creates an instance of the sensitivity analyzer. And then the df data frame attribute of the sensitivity analyzer already has the results of doing this nested loop and collecting all the results and everything that have been done here. And we'll see in a minute here in the example that it's also similarly easy to visualize all the results as well. So let's go ahead and look at the Jupyter example for all of this. So the first thing that we're going to do is install the sensitivity package. And so this is something that you would run in a terminal, but Jupyter has this shortcut, as mentioned in the video on installing packages, that you put the exclamation mark, that means run it in a terminal in the background, and then we want to do pip install sensitivity. And I'm going to go ahead and add in upgrade because I already have it installed and I know that I've released some updates for the package and I want to have all those updates here. So I'm going to run that and it's going to look like it's doing nothing for a little bit, and then eventually it will pop out all the output from the result as we see now. And we can see that it successfully installed sensitivity. And as of making this video, 0.2.5 is the current version. You may just get requirement already satisfied for everything if you already have the newest version. And then if you run that first, you don't really have to do this step, but I'm just going to go ahead and restart the kernel for good measure. So now let's go through what the process looks like kind of the original way without the sensitivity package, and then we'll go into how to use the sensitivity package. So I'm going to import pandas that we'll use for collecting the results, and I'm defining the model function. So again, this can be absolutely anything. It can be your full financial model. Here we're just taking one number to the power of another number. It really doesn't matter what happens inside of here. That's the beauty of using functions. We can plug whatever functionality we want into this structure, and it works exactly the same. So when I run the model, I can get a result from it. So then if we want to look at 3 different values for x1, 3 different values for x2, then when we look at the nested loop, we can see that we get basically each combination, each pairwise combination of the inputs. So we get 9 total cases from 3 cases for each. Then we can add in calculating the model, running the model. So that's just calling the model function on the inputs from the loops and then getting the result. And here we're just going to print out the result as the next step. And then after that, let's collect the results. So taking the same loop, but now adding to it that instead of just printing the result, I'm going to have an output list, and I'm going to append to that a tuple which contains each of the inputs as well as the output. And then we can see that we have each pair of inputs associated with the output. Then we can put that into a data frame. So if we give a data frame a list of tuples and then the names of the columns, it's able to create a data frame from that. And then we can add some styling about the result. So here I'm adding a red, yellow, green color map to the Y column, the output column, which is now showing the high results in green and the low results in red. Then the other way to go about it is to use a hexbin plot. So that's also off of df.plot, just like we had done for all the other plots with pandas. And you give it x and y as your two input variables, and then c, that stands for color, is going to be determined by the outcome variable. And then this grid size says, going in each direction, how many like blocks should there be. This is like 3x3 blocks in the graph. Again, we pass that color map, red, yellow, green, and then this share x equals false makes all the formatting work correctly. So that's without the library. And then with these color maps, you can do _r to reverse the color map if it turns out that a low number of the result is a better thing, like years to retirement. We want to retire quicker, so there you would want the reversed red, yellow, green color map. But all this is a little bit involved. It's not super complicated, but there's a fair number of steps here. So the sensitivity package is going to make this all easier. So with the sensitivity package, we set up that dictionary of the inputs, and then we create the sensitivity analyzer. And we pass to the sensitivity analyzer that dictionary, as well as the model function. And notice that there's no open close parentheses here. That's because we're passing the model function itself and not the result of calling the model function. As soon as you put the parentheses, it's going to call it, evaluate it, return the result. We want to pass the function itself so that sensitivity analyzer can use this function that we're passing to it. So you run sensitivity analyzer and you'll see this progress bar go by. Here, the model didn't take any time, so it basically filled up immediately. 450 iterations per second. And you'll see it ran 9 iterations in total because we had 3 times 3 cases of inputs. So, there's definitely a chance that you can put too many inputs here and you get a really huge number of cases, and then you'll see this thing just taking forever, and then you should reevaluate how many inputs you want to look at. So then we've run sensitivity analyzer. Now we can get that same exact data frame, which we had seen before, but just it's already there, ready for us. We didn't have to go and calculate it. And then for the plots, we just do sa.plot, and then we have that hexbin plot. Easy as that. And we can also get the styled data frames by doing sa.styledfs. And that is going to give you the data frame with conditional formatting applied to it. And there are options that you can apply to the sensitivity analyzer as well to customize the output. And so I'm going to do a few different things here. So I'm going to give it some labels so that it'll change out x1, x2 for whatever names I want to call the inputs. I'm going to pass grid size of 3 so that it makes larger blocks here. Reverse colors, that was like adding _r to the color map before. It just flips the color map. Then you can also pass a custom color map. And if you want to know what are all the color maps you can use, just Google matplotlib color maps. That will take you to choosing color maps in matplotlib, and you'll see all these different ones that you can pick. So all these names on the left are things that you can pass to color map to get a different color map. And then, yep, that's all the options. So then I'm going to run this and then plot. And now we can see it has the large grid size. It has the new color map. It's reversed the color map. And we see the labels coming in instead of the actual names of the arguments. And we see that on the data frames as well. And the really beautiful thing about this library is you can keep adding more inputs that you're looking at, and you really don't have to change your code at all. It works in the exact same structure. So here we have a second model. It's got 3 inputs this time. And now we've got our dictionary, which has the 3 different inputs and 3 different values of each. So we run that. This time we can see it ran 27 different cases, 3 times 3 times 3. And what we see when we plot it is that now we get 3 different plots all at once without having to do any extra effort. We get x1 versus x2, we get x1 versus x3, and we get x2 versus x3. So we get all the different combinations of the different inputs and the relationships between them. So really easy to run a lot of different inputs and visualize it all at once with just a couple lines of code. And then we'll see the same thing with the style data frames. We'll get 1 verse 2, 1 verse 3, 2 verse 3. And as you continue to add more inputs, you'll get all those combinations, so it can become a lot of output really quickly. And if you need to look up so this styled data frames, you can see I saved it into styled dict. It does automatically print out the results, even if you save it into a variable. You'll see what we have here is actually a dictionary where the keys are tuples and the values are the styled data frames. So you can also look up, reference any of the individual results that you want to look at. So we can also do some additional styling. We can change the number formatting of the results as well. And you can pass this in either when you create the sensitivity analyzer at the beginning or to the style dfs command. You can pass the number format. And this number format works exactly the same as the pandas number formatting that we learned from the styling pandas data frames lecture. Where you basically put the same kind of string as like an F string, only you don't put the variable here. You just put nothing there and then a colon and then the format code. So you can see this is doing dollars and then formatted with commas and 0 decimal places. And we see that all coming here as well. So that covers the introduction to sensitivity analysis in Python. We'll come back next time to add the sensitivity analysis into our existing dynamic salary retirement model. So thanks for listening and see you next time.